What an interesting topic. Modules. Hello and welcome to another Python tutorial from ZomCast. I'm Mehdi and this is ZomCast 19. Before we get started with our weekly tutorial on Python, let me say a very big happy Christmas and happy New Year to all the audience of this podcast and all people around the world. So let's get down to the topic. I switch over to Visual Studio Code and actually I switch over to Firefox. Before we get started with getting our hands dirty with coding, it's good to read a little bit basics about Python modules. Yes, modules. First, the definition. If you quit from the Python interpreter and enter it again, the definitions you have made, which means functions and variables, are lost. Therefore, if you want to write a somewhat longer program, you are better off using a text editor to prepare the input for the interpreter and running it with that file as input instead, just like what we are doing in this course. This is known as creating a script. So as I told you before, when we create a file like functions, tutorial lists, string tutorial.py, app.py, and in fact any Python file that you create is called a script. Back to Firefox. As your program gets longer, you may want to split it to several files for easier maintenance. Let's say you have a lot of files in your project and you want to access different definitions that you have created in various other scripts. You may also want to use a handy function that you have written in several programs without copying its definition into each program, just like I said. To support this, Python has a way to put definitions in a file and use them in a script or in an interactive instance of the interpreter. Such a file is called a module. So, again, the definition, Python has a way to put definitions in a file and use them in a script or in an interactive instance of the interpreter. Such a file is called a module. So in fact, a module is kind of a script, but the main purpose of it is including it into some other script so that the other script can use the definitions that have been made in this file, in this special script. And this special script is called a module. Definitions from a module can be imported into other modules or into the main module. So, other scripts or other modules can include the definitions from other modules, the collection of variables that you have access to in a script executed at the top level and in calculator mode. So the main module is in fact the collection of variables that you have access in a script executed at the top level and in calculator mode. When you run a Python script just like we did, for example, if I run Python functions, this functions.py will be the main module because it is the main script that I am executing. And also if I run the Python interpreter and define some variables here like num1 10 num2 20, the variables that I have defined in this calculator mode of the interpreter can comprise or make a collection that is called the main module. Alright, now that we have read this definition, it's good to see a little example. There's a small example here on the website. You see docs.python.org, the page for tutorials on modules. A module is a file containing Python definitions and statements. Okay, the file name is the module name with the suffix .py appended. Within a module, the module's name as a string is available as the value of the global variable name. So inside a module, if you get access to this special variable underscore name and underscore, the name of that module, which means the name of that file, will be printed, will be accessed. For instance, use your favorite text editor to create a file called fibo or fibo.py in the current directory with the following contents. Alright, let's actually do it. I'm gonna copy the content of this snippet and create a file as the instructions say, fibo.py, Control N, and fibo.py. I put the definition here. I save it as fibo.py. I remove this first line. I just wanted to give a hint to Visual Studio Code to save it with this name. Alright, now that I have the definition in the current directory, sorry, I forgot to show you the code. I just created a new file. I named it fibo.py and I pasted the content that I copied from the page. And now that I have that, because it is in the current directory I'm working on, I can access it in calculator mode. In calculator mode, I can import it as the instructions on the website say. Look, now enter the Python interpreter and import this module with the following command. So we switch back to code and I import fibo. You see that in order to import a module, you don't need to specify the py extension. All you need to do is just specify the name without the py extension. And if it is in the current directory or in a place that Python knows, Python will have access to it and will import it for you. Alright, now that we have access to it, actually we can call the functions that are defined inside this module. Look, inside fibo we have fib and we have fib2, so we can access them. Let's actually call them. Alright, print, what is this? What kind of printing is this? Print a while a less than n, print a, and then end it with space or tab, and then a and b equals b, and this is multiple assignment actually. The value of a becomes b, and the value of b becomes a plus b. Alright, and this is printed. First it starts from 0 and 1, a is 0, b is 1, and then it goes up to the value of n. For example, if this n is 10, it starts from 0, 1 and goes up to 10. While a less than n, then prints 0 and then ends it, and then says a equals 0 and a equals 1 and b equals a plus b, 1, because 0 and 1 are added up to make 1 again. Next time this is the third number is 1, a will be 1 and b will be 1 plus 1 or 2. Alright, let's make a call to these functions. We don't need to be specific on the implementation details. So fibo dot, look, I enter dot and then press tab, which displays the available functions inside that module. So in order to call the first function, I say fib 10. There we go. You see that it displays it. All right. And for the second function, we call it this way: fibo dot fib to 10, and it prints it this way. Actually, it returns something. It doesn't print anything. It just prints. It just returns the result that it creates. It creates a sequence like an array, and then it returns it to us. So basically, you learned what a module is. A module is a collection of definitions, and it is not different from a script. It's in fact a Python script, but it is mainly used to create some definitions that will be accessed by including or importing that module in some other script. And you can import a module in calculator mode or in some other let's say in some other script that you have created. Let's say we have another function. We have app.py, for example. Look, we have app.py, and here at the end of the file we can make a call to fibo.py. In order to do that, we need to access it. So I close the interpreter because we don't need it anymore. Actually, before removing it, let's make a call to name. I'm gonna print name. You see that the name of the module, the main module, is here main, because we are in the calculator mode. When you are in calculator mode, the name of the module is called main, because it's the main script or main Python application that is being executed. Okay, now I close it and back to our app.py. Here I import fibo.py this way. In the beginning of the file, I type import fibo, and Visual Studio Code also helps you complete it and shows the suggestion for the module name. Now that I have imported it, first you see that its color is a little bit weak. The color is dull a little bit. Why? Because we haven't used it yet. If we use it, it will become lighter and stronger. The color will change to a stronger variant. So I call, for example, print calling fibo.fibe function, and I call it fibo.fibe. I pass it a number like 50, and it will print it for me. Actually, when I make a call to it, it will print the result of the Fibonacci series for me until that number. So it will be 0, 1, 1, 2, 3, and so on. Also, let's add the call to the second function from that module, calling fibo.fibe2, and then fibo.fibe2. Again, I pass in 50, but we don't have to. It can be any number. And let's run the script. There we go. Calling fibo.fibe, you see that the result until that number, the Fibonacci series until that number is displayed for us. And after calling the second functions, you see that nothing is displayed. Why is that? The reason is that we know inside fibe2 function, actually we don't print anything. We just do some calculation for the series and we return the value as a series. So we need to use it in some print statement. Print another f string fibo.fibe2 result, and to use the result we actually use the result that was calculated by fibe2, that returned by fibe2. Again, I run it, and there we go. You see that the value returned from fibe2 is used in the f string and displayed to us. So this basically tells you how to import a module into your application, into your Python application. One thing that I see worth mentioning here is that you don't have to do all your imports in the beginning of the module or script. Actually, you can do the import anywhere just before using it actually. So since this is the first line, line 22, that I'm making a call to Fibo, I'm accessing the Fibo module, I need to import it at least here. And now Python knows what Fibo is and what to do with it. if I move it after, like if I move it after the use of it, you see that we see a warning because VS Code doesn't understand. The Python interpreter doesn't understand what 5.0 is. So before using any module in your script, make sure that you import it. Alright, so what I said here actually is for custom modules in the current directory. So you see that it's very easy to define a module with some definitions and then import it into your script and use it. What if we have some different directories in which we have defined our modules? For example, let's say that I have defined a directory called, for example, models, and inside that models I have defined different classes and different utilities. Actually, let's change it to util, like utils, and imagine we have different modules in it that do something for us. For example, we have a math module, we have a words module, and any of these do something for us. First, the math module, I define a function here, like a function that does a simple power, takes a number to a power defined by the index. For example, define power AB, and what it does, it actually returns so when we take A to the power of B, we should create for I in range B which means go from Python range to n. Okay, go from 0 to b, and 0 to actually b minus 1. Alright, actually we can do that from 1 to b when we say range, and then we multiply a by itself. So a equals a multiplied by a, and then we return a. Let's add some small documentation for it. Return the value of a to the power of b. So this is a math module that I have created. It has a utility function called power, and what it does, it just does some simple power mechanism, power calculation, and returns the result for us. Another is the words module. It's, for example, going to say a very simple message, diff say it just reverses a message, reverse str or reverse text. It returns a text, it receives a text of the type a string, and it reverses it. Okay, how do we reverse a string in Python? To reverse it, let's say we just text, if I'm not mistaken, this reverses it. It's not very important. If this is not working, sorry, I'm just trying to explain the purpose of modules and how to use them. Okay, reverses the given string and returns it. It's a good convention to add some documentation, inline documentation in the beginning of your functions, because later it will help you a lot, and not only yourself but also other developers that are using your code. You can see that when I hover over the name of the function, it shows me the documentation and the purpose of this function. Alright, now in the app script, I'm going to use these modules. How do I do that? How should I do it? First of all, we need to import it, okay? Again, as the convention I told you, is better to do your imports in the beginning of the script, because it's easier to keep track of it and later remove the ones that you don't really use. Import what? I'm going to import a module, but note that this time the module is defined in another directory or package, as Python calls it. It's not in the current directory. Let's see what happens when we do it. Import math. Actually, I'm going to import math from my own module, not the math from Python standard library, because Python itself also has a math module. So it's important that you specify this distinction for Python and avoid confusion. And actually, one of the good things about modules is that they allow you to distinguish different modules, although they might have the same name, but since they are in different packages, you can easily distinguish them. For example, my math is inside the utils package, so I say utils math. And since I want to later use this easier, I import this as something. I say import utils.math as my math, just like that. And I also want to import words, so I say import utils words as words. So whenever I use the name words inside this script, it means that I'm referring to utils.words, the words module from the utils package. Alright, now let's use it. Actually, I'm feeling cold. I need to wear something. I put on something. Sorry. Okay, I'm back. First, let's use our math module, do some operation with it. I say print making a call to utils.math.what.power. I say print f string, and I want to print the result of a simple calculation. I say my math dot power, and I enter two numbers like 2 to the power of 10. It should be 1024. Okay, let's also make a call to our second module's reverse function, I say print making or calling, actually calling utils dot words dot reverse text. Its name is reverse text. Print f string. It's called words dot reverse text. Let's give it its text like universe. Okay, the delimiter problem. Universe. You cannot use single quotes to delimit a string and then use another pair of single quotes inside the text. You have to make a difference between the outer delimiter quotes and the inside ones. Okay, do you think that it will run when it will work perfectly if I run it? I doubt it. There we go. There's some problem. What is it? Invalid syntax. Oh, our for loop looks like had a problem. Which line? Import utils.math. Invalid syntax. Which line? Line 1. So why is that? Why is that not finding? Actually looks like it doesn't find the utils package and the module defined in it. Let's find a cure for this. Let's find a solution for this. If you go back to the Python documentation page and look at the definition of modules that are inside packages, the module search, standard modules, letter function, packages. Look, if you read this, packages are a way of structuring Python's module namespaces by using dotted module names. For example, the module name AB designates a submodule named B in a package named A. Just like the use of module saves the author of different modules from having to worry about each other's global variable names, the use of dotted module names saves the authors of multi-module packages like NumPy, or Pillow from having to worry about each other's module names. So, as I said before, it allows you to structure your files and your modules in directories which are called packages. But if you notice, inside the sound, for example, inside the sound directory, there's also a file called __init __.py, and inside every sub module or sub package of that main directory, you see again the same file __init __.py, and inside effects as well, and inside filters as well. What this tells us is that in order to tell Python to treat the contents of a directory as modules in a package, you have to add an empty file called __init __.py. And the interesting thing is that you only have to add that file and nothing in it. You don't have to add anything in it. Just per se, if you create the file, it usually works. And we don't need to worry about what magic Python does. It just we can think about it just like it tells Python to treat that directory as a package and the files in it as modules. Alright, let's make that change by adding a file inside utils directory by the name of underscore underscore init underscore underscore .py, and back again to our app.py file. I run it and it should work, but it doesn't work again. Why is that? Oh, sorry. Actually, import import that module, import utils dot math utils dot math as my math. I don't understand. Why is that? Let's comment this out. Invalid syntax. Why? What invalid syntax we have here? What are you talking about? Line 1, invalid syntax. It shouldn't be like that. Look, I didn't make much change in the file. In the beginning of the file, I just removed the two definitions that I had for importing the two modules, but it doesn't work. It's weird. Very weird. Oh. So after closing it, it works. Alright. I comment this out. I uncomment these two definitions and it should work. Very good. You see that? Oh my god. You look at the result of utils math power. It works. And it shows the result of our power. But looks like our calculation was wrong. The math was wrong. What if I remove that init file that I told you about? My guess is that our modules will not work anymore. I change it to something like ini, for example. My guess is that our code will break. Universe. Oh, our universe is also working. Our second function. The reason why this is working is probably because this init has been already created. If I remove this directory, this cache directory, I think it will not work. What? It's working. But generally you need to add that file in modules. The reason why it's working, probably it's because the path is very simple and easy to access. If you had it in another, if you had another package like, if you had another package like utils2 or package2, for example, it would probably create a trouble for you because the two packages couldn't find each other. If you wanted to import one thing from the other package into the other package, it will result in some problem. But since currently the packages that we created, the modules that we created inside our package are kind of embedded and are subdirectories of our main directory. It's easy to find. It's easy for Python to find it, and you don't need even to include this file in it. But it's good practice to add it to all of your directories that you create that contain modules. So make sure you add this file. And again, I mentioned that this file contains nothing. It's just an empty file, and it's used to recognize and to indicate to Python that this directory is a Python package and a place for Python modules. All right, before I wrap up, let's fix our problem with this power function that we had. Our power function has a very bad problem. So the result should be 1024, but it's not 1024. 1024 to 2 by 2 becomes 4, and then 4 by 2 becomes 8, and 8. So why is that not working? A by A. First A by A. Turn A. First A by A is 4, and then 4 is stored on the left, and then we say 4. Oh, no, actually 4 is multiplied again by 4. It shouldn't be that. We need to store our initial number, and then 4 by 4 becomes 16, and 16 is multiplied by 16. This is wrong. 16 must be multiplied by 2. So the initial number should be kept. Base. We keep the base here. And each time we do this calculation, A is multiplied by base and then stored in A. So 2 by 2 becomes 4, and 4 by 2 becomes 8, and 8 by 2 becomes 16. Okay, let's run it again and see if it's resolved. There we go. 1024 is correct answer. Alright, that's it for how you define modules. Just make sure when you define modules inside packages, include that init.py file, which is very important, especially if you are creating complex structures and you are creating connections and imports into each other from each other. Also, let me mention something. There are some modules and packages in the Python standard library that you can use directly without needing to worry about which package they are in. The maintainers of the Python programming language has made it very easy to use them. For example, we have the sys package. We have the sys module. You can easily import it. This is one of the system modules that give us some system functions. For example, the exit function that allows us to exit a script. And actually these modules might serve several purposes. One of them might be giving you access to system functions like what I said, and the other is giving you more power, giving you some efficiency like the math module. In fact, import math, for example, and we can use them, for example, here. In the end of the file, we can simply print something. We can do some operation with both of these modules and then exit. Math dot cosine, math dot cosine 45, cosine of 45, as I remember it was 1, I think, if I'm not mistaken. Math cosine 45, and then exit. Print, actually sys, we are using one of the capabilities of the since of the system module, or sys, exit 0. Because we have done everything and we are just exiting the script, we are making a call to it. This is a little bit stupid here. You don't usually do this because the script will exit anyways, but this is just to show you how you can use the functions defined in the system module. Let's run it. There we go. Cosine of 45 is 0.5253, so it was not true. The answer that I gave was wrong. Alright, and the script is exited using this method, although it was not needed. So basically there are several types of modules that you define yourself and use it to help you be more productive and reduce redundant code and boilerplate code by saving yourself some functions that later you can import and use them in other projects or in other parts of the project. And also we have the system modules, the standard library modules that are either modules that help you be more proficient, more efficient by giving you some capabilities like the math, like the math library, like the math module, or the system module sys in Python that allows you to access system functions. Okay, I hope that you liked it. Sorry for making this a little bit long and boring maybe. I hope that you liked it. Please, if you liked the video, give it a thumbs up and subscribe to my channel. Again, Happy New Year. I wish you a very healthy and prosperous year this year, and full of programming adventures and success. To all of you, take care and see you in the next episode.